Good morning, students. In today's class, we'll discuss about serial processing, concurrent processing, and the concept of threads and multi-threading concept. In our last sessions, we discussed about various CPU scheduling policies such as first come first serve, shortest job first, round robin, priority scheduling, multi-level scheduling, multi-level feedback scheduling, multi-processor scheduling, etc. So these CPU scheduling policies are broadly classified into two types. One is non-preemptive CPU scheduling policy. The other one is preemptive CPU scheduling policy. In case of non-preemptive CPU scheduling policy, once a process gets the CPU, it will release the CPU to the next waiting process only after completion or only if the currently running process has any IO operation. Whereas in case of preemptive scheduling CPU scheduling policy, once a process gets a CPU, after a certain time limit is over, automatically the CPU goes to the next waiting process in turn. We also studied the merits and demerits of each of these CPU scheduling policies and also how the various CPU scheduling policies are compared based on certain criteria like throughput, turnaround time, waiting time, response time, CPU utilization, etc. In today's class, we'll be discussing about serial processing, sequential processing, concurrent processing, threading, etc. At the end of today's session, you will be understanding the differences between sequential processing and concurrent process, the concept of context switch, what do you mean by a thread, and the differences between a thread and a process. Let us consider sequential and concurrent process. A sequential process, as the name indicates, it is used to describe processing that occurs in the order in which they are received. The first process occurs first means that will be executed first, followed by the second process, followed by the third process, and so on. So in whatever order they are submitted, in the same order they are executed one after the other. Hence, it's called a sequential processing or linear processing. But in many situations, what happens is the linear processing or sequential processing is not suitable. So a concurrent processing is one where several processes are executed parallelly. So several more than one process can start execution simultaneously, which results in better performance. But generally, for a concurrent processing, we need multiple processors. Each processor takes care of executing one process. That too, there are many processes are executed simultaneously. Suppose there are three processes P1, P2, P3, and each process needs 30 milliseconds of CPU. In case of sequential processing, P2 will be executed after execution of P1. P3 will be executed after execution of P1 mean, P2 mean that altogether takes 30 plus 30 plus 30, 90 milliseconds. Whereas in case of concurrent processing, all the three processes P1, P2, P3 can be executed parallelly by using three different processors. So P1 also started work executing P1. Processor P1 start executing process 1. Processor P start executing process P2, and third processor start executing third processor. So within 30 milliseconds only, you can complete all the three processes. So hence, the performance is better in case of concurrent processing. The tasks are, in case of concurrent processing, the task or the program is divided into subtypes or subtasks, which are then assigned to different processor to perform simultaneously. The large and a complicated process is divided into smaller and simpler subprocess. Each subprocess will be start executed parallelly by different processor. Hence, a concurrent processing is also called a special type of parallel processing. Let us take the example of or the purpose of context switch. A context switch is a technique or a mechanism. There, what happens is if your processor is executing a particular process, say P1. During execution, suppose the process has some IO operations to do. Then what happens is the current status of that particular process has to be stored in the process control block, like its current status, CPU utilization time, CPU register it has used. All this information should be stored because during the execution of a current process, a new process arrives or an interrupt occurs where the priority of the newly arrived process is higher than the currently running process. Means the complete information about the process, currently running process, should be transferred to the process control block, and the CPU finish executing the high priority process. After completion of the execution of the high priority process, the CPU fetches the information of the previously executed job from the control block and start executing from the point where it left earlier. So this method of switching or storing the information of the currently running process in the process control block and restoring it after executing a high priority process is called as a context switch. Using context switch technique, a context switcher enables multiple processes to share a single CPU. So here what happens is the processor start executing P1. Suppose that particular process has any IO operation is there, or whenever a high priority process arrives in these two conditions, the complete description or complete status of the currently running process should be transformed to process. It's stored in the process control block. Then the CPU start executing another process. So there what happens is more than one process will share a single CPU. It's a very, very essential in case of multitasking operating system feature, because Unix is one example of a multitasking operating system which uses this context switch context. Because in the case of sequential processing, whenever a process has any operation is there, unless and until that IO operation of the currently running process is over, the processor cannot take another process. Whereas in the case of concurrent processing, during the IO operation of the currently running process, or in that case, CPU will not wait till that IO operation is over. Automatically, it picks up the next process by switching the information of the currently running process to its process control block. After completing the high priority process, it goes back there and restore it from the point where it left earlier. When the scheduler switches the CPU from executing one process to another, the state from the current running process is stored in the process control block. After that, the state of the process to be run next is loaded from each PCB. Suppose there are two processes, P1 and P2. Your processor is currently executing P1. All of a sudden, the P2 process arrives. The priority of P2 is higher than P1. Then the complete description of P1 should be stored in its process control block. Then the complete information of the information about the process P2 is fetched from its process control block. After the execution of P2, then the processor once again go back to the PCB of process 1, fetches all that information and start restoring from that point. This is how a CPU is executing multiple processes in parallel. It's executing P1. All of a sudden, if that process has any IO operation or any new process arrives, the status of P1 is stored, then start taking P2. After executing P2, once again it goes back and restores the process P1 and so on. This is executed in parallel. Dispatcher. Dispatcher is a module in process management which gives the control of the CPU to the process selected by the short-term scheduler. Generally, there are three types of scheduler: long-term scheduler, short-term scheduler, and medium-term scheduler. The purpose of long-term scheduler is to switch the process from job queue to the ready queue. Out of our several processes available in the ready queue, only one process should be given the CPU. So that is decided by the short-term scheduler. Dispatcher module gives the control to the short-term scheduler for the process selected by the short-term scheduler. That involves three major steps: switching context, that means the information of the currently running process should be stored in its process control block, switching to the user mode, and jumping to the proper location in the user program to restore that program. So these are the three main steps involved in dispatcher. A dispatcher latency. A dispatcher latency is the time it takes for the dispatcher to stop one process and start another process. So whenever process 1 is executing, after execution over, then the CPU should be given to the next process. So it takes little time in leaving from process 1 and goes to process 2. The time we call it as dispatch latency. Thread. Thread is nothing but sometimes a particular process is broken into several instructions or several small unit of task. Each unit of task is called as a thread. A process means any program in execution. The currently running program is called as a process. Process control block controls the operation of any process, because the complete information about the process is available in the process control block. The process control block contains information such as priority of the process ID, state of the process like new state, ready state, running state, etc., CPU register, etc. A process can create other process. A process P1 can create P2. P2 can create P3, like and so on. Then each process created by the main process, we call it as a child process. Process takes more time to terminate because a process is a huge unit of task. So that's the reason a process is divided into smaller pieces. Each unit, we call it a thread. Hence, a thread is a segment of a process, and a single process can have multiple threads. Sometimes many threads can be started executing simultaneously by different processors. That concept, we call it a multi-threading concept. Any thread you take, it has three different states: running state, ready state, and blocked state. So generally, as a whole process, it takes more time, whereas single thread will be executed very fast and it takes less time for termination. A thread is called as a lightweight process because a thread will not take much time, whereas a process is called as heavyweight process. Thread provides a way to improve the application performance through parallelism, because single process can have multiple threads. All the thread can be started executing simultaneously. So it's a concept of parallelism which results in better performance. That thread denotes an approach to improve the performance of an operating system by reducing the thread overhead, which is equivalent to classical process. Every thread belongs to one particular process. Suppose there is a process called P1, it can be divided into 5 subtasks, mean T1, T2, T3, T4, T5, mean each one is considered as a thread of the process P1. And no thread is allowed outside any process. Every thread must belongs to one process because a thread is a unit of a process. Each thread has its own program counter, just similar to a process having its own process control block. Every thread also has its own program counter that keep track of which instruction to execute. So any thread has three components: program counter, system register, and stack. Program counter is a register that indicates a thread can have multiple lines of code. Then each line is stored in different addresses. Then a program counter is a register which tells the address of the instruction to be executed next. System register, which holds the current working variable, and stack, which contains the execution history. Suppose the execution of an instruction takes three variables A, B, C, etc. Then all the values of A, B, C are stored in system register, and stack contains the execution history. It stores the information about which instruction has executed first, which instruction has executed last, etc. All this information about the execution process is available in stack. So this is an example of a process with one thread, and the right hand side we have a process with multiple threads. The first example I told earlier, every thread has three parts: register, counter, and stack, and every thread has certain data and file, and we need some code that gives the description about that thread. Every thread is a unit of it. So each thread can contain 2, 3 lines or 4, 5 lines, etc. So every thread will have certain line of code. So in the second example, there are how many threads? 3 threads. First thread has its own register, counter, stack. Second thread also has its own register, counter, stack, like the third thread also. And each thread has its own data and file, and each thread can be executed parallelly. Each thread has its own lines of code, and they can be executed parallelly. The first one is an example of single process P with single thread. Second one is single process P with 3 different threads. Let us discuss the major differences between a process and a thread. A thread is a unit of process. So one process includes several threads. The first one is a process is a program under execution. Any program which is currently executed by the CPU, we call it as a process. A thread is a lightweight process that can be managed independently by a scheduler. Context switching time. Generally, process take more context switching time because they are heavy, whereas thread require less context switching time because they are lighter than process. That's why thread is considered as a lightweight process and process is a heavyweight process. Memory sharing. Independent, and every process is independent and they don't share any memory, whereas for several threads can share the same memory. Communication between Process require more time than the time of communication between the thread, because thread is a small unit of time. So generally, communication time is more for process than for the thread. Blocked. If a process gets blocked, remaining process can continue execution. Whereas if a single thread is blocked, all its peer thread also gets blocked. Resource consumption. Process require more resources than threads. Dependency. Individual process are independent of each thread. First process can have its own number of thread. Second process can have its own number of thread. Third process can have its own independent thread. Can have its own thread. Then process P1 and P2 are independent. P2 and P3 are independent. Whereas threads within a particular process are dependent on one another. Data and code sharing. Process have independent data and code segment. A thread shares data and code segment. Time for creation. Process require more time for creation because it is heavy, and thread require less time for creation. Time for termination. Since a process is a heavyweight process that require more time for termination than the thread. So these are some of the major differences between a process and a thread. Review question. Define sequential process and concurrent process. Explain briefly context switch. Context switching is a major concept where the information of the currently running process should be stored in its process control block before fetching the next process for execution. After executing that process, then once again, the information about the previously executed process should be brought it from its process control block. The switching we call it as a context switch. Bring out the differences between a process and thread. Several differences I have mentioned in the table. And let us revise what we have studied in today's class. A thread is a heavyweight, lightweight, medium weight, none of these. It's a lightweight. Concurrent processing is similar to distributed, networking, parallel, none of these. A concurrent processing, another name is parallel processing. Dash holds the address of next instruction to be executed. Program counter is a register which holds the address of next instruction to be executed. A dispatcher gives the control of the CPU to the process selected by which scheduler? Short-term scheduler. The correct answer is D. Context switch time is more for process when compared to thread. So the correct answer is A. Okay, students, in today's class, we learned the differences between concurrent process and sequential process, the concept of thread, the concept of multi-threading, the differences between process and a thread, and also the concept of context switching in process management. Okay, we'll wind up today's class. Thank you.